Hello. All right. Hey guys, so I just wanted to make a video to help you complete your test 1. I'll be doing this for every test, showing you how to complete the test 1 review, because as you are probably aware, we pull from these types of questions for your test. So I'm going to go through this question by question and show you, explain to you what the answers are, why they're correct, and then if we need Excel, just showing you how to do it in Excel. And I apologize in advance if you hear dogs barking. I have 2 dogs, and sometimes they like to play. So let's just get started. Question 1. The histogram below displays the distribution of 50 ages at death due to trauma that were observed. Which of the following best describes the shape of the histogram? So just looking at this shape, you'll notice that we have a bulk of our data centered around 20 to 30 years of age, and the data gets pulled, and we have fewer and fewer observations as people get older. So that would indicate that we have a skewed distribution, and the direction that it's skewed is what type of skewed it is, I guess you want to describe it like that. So you'll see that the tail, the ends get pulled to the right. So we say that's right skewed. So then we have these 4 options here: left skewed, right skewed, with no outliers, and then right and left skewed with a possible outlier. So I'm going to go ahead and say it's right skewed with a possible outlier, because we have this distribution here at 90 years of age. So we're going to say that that could be a possible outlier and see what it tells us. Here are the number of hours. Question 2. Here are the number of hours that 9 students spend on a computer on a typical day. What is the mode? Now, you could probably, with this data set, since it's so small, be able to figure out the mode without doing any sort of calculation in Excel. The mode, if you remember, is the value in the data set that occurs the most. So we're looking to see which data value occurs most frequently. So we have 1, 2, 2 5s, 1 7, 3 11s, a 14, and a 15. So because the 11 occurs the most, we can say that that's the mode. If you want to do it in Excel, just go ahead and type these values in: 2, 5, 5, 7, 11, 11, 11, 14, and 15. And what's nice about Excel is that, for the most part, the functions that you need to use to statistically determine these different types of, in this case, measures of central tendency, their names are about what you're trying to find. So in Excel, before you do any type of function, you always want to start with the equal sign. And since we're looking for the mode, you can just do M-O-D-E. And you see mode multi, mode singular. And you can kind of just click on it, and it tells you exactly what it is. Returns a vertical array of the most frequently occurring values in a range of data set. We can do that. So mode multi, you can just go ahead and do that one. And all you got to do now is highlight your values. You can close it with the parentheses if you choose, and then just hit enter. And you'll notice that this function quickly told us that the mode was 11. So this is super helpful if your data set is very large and you can't immediately see what it is, or even if your data values are not even sorted. They're all kind of scattered about, so you really can't figure out what the mode is in your head. Question 3. A recent survey asked 105 students, how many hours do you spend on a computer on a typical day? Of the 105 respondents, we can see the values are here. And we want to know, what is the average number of hours spent on the computer? So this right here, I'm going to delete these just to keep Excel kind of clean by question. We're going to go ahead and copy this into Excel. All right. So we have this data set in Excel, and we want to find the mean. Now, what we do not want to do is just find the average of these X values, or the computer hours. And you can kind of see, if you highlight some sort of array in Excel, it tells you the average right away in the bottom. Average is 5, which you can kind of just see from the list. But what this data set is, it's a frequency table, and it's telling you that one student spends 1 hour a day studying or on the computer. 3 students spend 2 hours on a day. 11 students are on the computer 3 hours a day, and so forth. So technically, to find the average, we would need to use our data set of, we have 1 1, we have 2 3s, we have 11, 3, and do all of that. That takes a very long time. So what we can do is kind of use this function in Excel called sum product to help us figure out what is the sum of all of the observations, because that's how you calculate the mean. You add up all the observations and you divide by the total number of observations. So to find the mean, we're going to do sum product. Highlight one array, highlight our x values, and then we also have to highlight how many times those values occur. And so that value is 573. Now that's not the mean. That just tells us the sum of all of the observations. So if we go back into that formula, we now can see, all right, let's divide by the total number of observations, which it tells us in our directions 105. We can just go here and divide by 105. And this is our mean. We can also highlight this one row, and you'll look at the bottom of my screen, it says sum 105. Those should match. They should be the same. The only other thing we have to do now is make sure we round the correct number of decimal places. So it says round your answer to 1 decimal point. So we can go back into Excel and just shorten our decimals to 1, 5.5. What is the median number of hours spent on the computer? So this is going to require some thinking, I guess, because we can't really find the exact mean analytically unless we have the entire list of data. And in this example, we have it written as a frequency table. So what we want to do is kind of think about where the median would lie in relation to this data set. So we know that the median is the middle value of a data set. It's the 50th percentile. So we need to think about, well, what value would be the exact middle of our data set? Hey guys, sorry, my dogs got up and I just wanted to make sure they didn't bark. So anyway, so going back to this video, or to this problem, what is the median number of hours on the computer? We have 105 observations. That means the median is going to be the exact middle observation. So in an odd numbered data set, or in a data set with an odd number of values, the median is going to be the exact middle value. But if your data set has an even number of observations, it's going to be the average of the middle two. So we need to think about what value in our data set now is going to break up the distribution into two equal pieces. So that's actually going to be the 53rd observation in this case, because we'll have 52 observations to the left of the 53rd value, and then we'll have 52 observations to the right of the 53rd value. So we just need to figure out which of these computer hours results in the 53rd observation in our data set. So you can see from this table that number 1 is the first value. Considering computer hours up until number 2, we have 4 of our values. I'm just looking at the sum. Computer hours up until 3 hours, we're up at 15, a total of sum. So we have 15 of our data values up until this point. And we're going to just keep going down the table. From computer hour 4, we have 32 observations. And then we have computer hours number up until 5 is 52 observations. But we need the 53rd observation. So up until computer hours, up until 5, we have 52 observations. That tells us that the 53rd observation is going to be in computer hour number 6. And that is going to be our median. All right, same type of question. 91 observations, what is the average? So just like before, I'm going to copy this table into Excel. This one might be finicky. Yeah, this one's weird because it copies our table in 2 rows. So with this one, we're actually going to have to, I'm just going to type this in myself. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number students, 2, 6, 11, 25, 20, 14, 7, 5, and 1. The reason why I'm typing this in is because I know ahead of time that because it copied initially this first row as two different rows in Excel, Excel will give you an error message. And to find the mean, we're going to do the exact same thing that we did before. We're going to take the sum product of our number of hours list and the frequency list, and we're just going to divide by the total number of students, 91. And rounded to one decimal point. If you can't see that it's 4.7, you can just immediately go into Excel and use the decimal feature. All right, what type of region, what type of variable is region? So we have two types of variables that we're really concerned with right now at this point. We have categorical and quantitative. Categorical variables are those that describe, I guess, some sort of attribute about something, you know. What's your favorite color? Red, orange, yellow. What's your zip code? And even though it's a number, in that case, it describes a region, which is categorical. Quantitative variables are the ones that we typically use to find means and standard deviations and things like that. You can find the average. All right. Let's clear out this whole table. All right. A survey was conducted to see how many phone calls people made daily. The results are displayed in the table below. So let's just go ahead and copy this into Excel. All right. Ooh, no. What you'll notice is that Excel has converted this type of data, this part, into a date, and we don't want that. We want them to be, I'm going to make it a number in a second, but I just want to see if that'll work. 1 through 4. All right, like this. As an interval, just so we can kind of see. 5 through 8. If you're taking a test, this range will help you with your answer, but it's not necessary to do it like that. So we want, how many people surveyed make less than 5 calls per day? Well, that's just, less than 5 is not including 5, so we can just even use our frequency table and see that for people who make less than 5 calls per day, that's the people who made 1 through 4 calls a day, which is just 19. What percentage of those surveyed make at least 13 calls per day? I'm going to go ahead and just do the next question first, because we're going to need that part in part 2. How many people were surveyed? To find the total number of people surveyed, we're just going to add up this column. Now, you could, if you want to, use this function in Excel called sum, S-U-M, and just add them all up. 41. Or, if you don't want to, spend the time doing that, recall, you can just highlight that array, and your Excel will just tell you the sum right away. So now we want to know what percentage of those make at least 13 calls per day. So, at least 13, not 12. So we're going to say that this is, at least 13 means greater than or equal to 13. That means we're happy with people who make 13 phone calls, 14, all the way up until, in this case, 20. So we want to know what is the sum of the number of calls that are greater than or equal to 13, which we can kind of just see it's 4. But if you want to use the function in Excel sum, go for it. But we want the percentage, so we need to divide that by the total number, which is 41. So this gives you the proportion, but not the percentage. So we need to multiply this by 100. And we get 9.8. Let's just see if that is, you have not saved your work for 15 minutes. Well, let's save our work just in case. Save. All right, good. Going back to it, we're on number 7, right? Yeah. No, we're on number 6. So we can just see, just in case, if there are more decimal places to add. There are, and it does not say the number. Oh, round the nearest whole number. I'm sorry, I wasn't paying attention. So let's just round to the nearest whole number, 10. I already know that this problem has given you guys some issues in the past, so we fixed it, so we're just going to assume that it's fixed for this, and we'll see at the end. Question 7. What percentage of students earned a grade of less than 60? So, one second, I'm going to clear this in Excel. Maybe I'll go to a different sheet. We want to copy and paste this into Excel. Now, for those of you that don't recall interval notation, the bracket means inclusive. This interval here includes calls or grades of 40. The parentheses at the end means it's not inclusive. We're not looking at 50 in this interval. 50 is now going to be in the next interval. So this interval here really only includes values from, 40 to 49.9. If we're doing grades, though, it's probably going to be just the 49. So what percentage of students earn a grade of less than 60? So we want the number that are less than 60. So we can see that that's going to be 5. Divided by, now we need to look at how many total observations are in the table. Just sum them all up, then multiply by 100. And we want rounded to the nearest whole number, so that's going to be 28, but if you don't see that, just change your decimal so that there are none. And there we go. Question 8. The distribution of the amount of money spent by students on textbook in a semester is approximately normal in shape with a mean of 468 and a standard deviation of 23. According to the standard deviation rule, approximately 68% of the students spend between blank and blank on textbooks in a semester. So the standard deviation rule only applies to data that is normally distributed. And it's a way for us to kind of look at where a chunk of our data is going to be clustered underneath the distribution. So what it says is that if your data is normally distributed, the mean, median, and mode are all the same. It's the center of the distribution. And what the standard deviation rule tells us is that from the mean, if we go one standard deviation away in both directions, we can see that we're going to have about 68% of our data clustered there. If we go on a little bit further, to 2 standard deviations away, we have 95% of our data, and then if we go one more, we have 99.7. And this just allows us to kind of get intervals to where a bulk of the data is going to lie. So in this case, we want 68% of the students spend between blank and blank. Well, according to the standard deviation rule, that's going to be 1 standard deviation away in both directions. So we can just take our mean of 468 and subtract the mean, or subtract the standard deviation, and we can take our mean and add the standard deviation. And that will tell us 68% of our data lie between these two numbers, or approximately 68%. Question 9. The distribution of IQs is approximately normal in shape with mean 100 and standard deviation of 17. According to the standard deviation rule, blank percent of people have an IQ between 83 and 117. I'm not going to do this one in Excel just because we just did the question involving 68%. So if you look and see your mean is 100 and your standard deviation 17, one standard deviation above that mean is 117, and one standard deviation below is 83. So the standard deviation rule tells us that's going to be 68%. The distribution of IQs is approximately normal in shape with mean 100 and standard deviation of 16. According to the standard deviation rule, only blank percent of people have an IQ over 148. So in this case, we kind of have to think about how does the standard deviation rule break up our distribution into little pieces. So what we know, we first need to figure out, well, where is 148 in relation to the mean? So we have 100 plus 16. So 1 standard deviation away is 116. 2 standard deviations away, so 2 times 16. We're going to do an equal sign. 2 standard deviations away is 132. And if we go one further, 3 times 16, we have 148. So 148 is 3 standard deviations away from the mean in the positive direction. So what we know, we want to have an IQ over 148. So we know from the standard deviation rule that 99.7% of individuals are contained within 3 standard deviations of the mean. But we want outside of that. So we know that 100% of our data is going to be underneath the distribution, or the normal distribution. And we have the middle 99.7. And the middle 99.7 is within 3 standard deviations. and we want to know over that value. Well, we have to consider the fact that the the normal distribution is symmetric. So whatever percentage is above 148, that same percentage is going to be below 3 standard deviations the other direction. So we need to divide this difference by 2. And we get 0.15. 0.15%. All right, going back to this table here, what percentage of students scored a grade of less than 80? So we got to look and see, all right, less than 80 is going to be the sum of all the values in the counts that are less than 80. Remember, we don't include that 80 because it's not less than or equal to 80. So the sum of the values that are less than 80 divided by the total number of observations. And we want percentage, so we just multiply by 100. 71. Okay. The distribution of the amount of money spent by students on textbooks in a semester is approximately normal with mean 357 and a standard deviation of 27. According to the standard deviation rule, almost 0.15% of students spend more than what amount of money on textbooks? Well, we just did a question like this where our answer was 0.15%. So we know that that 0.15% or more than that, some value is going to be the value that is 3 standard deviations away from the mean. So we have 357 plus 3 times the standard deviation, 438. All right. The box plots below show the number of marshmallows in a bag as estimated. Okay? Which class has a greater variability in students' estimate of the number of marshmallows? So for variability, you're just looking at which one has the biggest spread, which box plot is longer. And that would be from here to Miss Apple. All right, same box plots. The box plots below show the real estate values of single-family homes in 2 neighboring cities, Tinytown and Big Bird. So which city has a greater percentage of homes with real estate values between $55,000 and $85,000? So box plots are helpful in kind of showing you what the quartiles of your data are, summarizing the data into 4 chunks of equal size. So 25% of our data in a box plot is contained in the first whisker. 25% of our data is in this left part of the box. 25% is contained on the right side of the box, and then 25% of our data is in the right whisker. Box and whisker plots never tell you the number of samples, or the number of values in your sample, or the number of values in your data set. So if we're looking at 55,000 and 85,000, here's 85, it's the median for both groups, and 55 looks to be about here, where the cursor is at. So what you'll see with Tinytown is that we have some values in our whisker, and then it looks to be about 25% in that first box up until 85. So we have this amount of values. For Big Bird, 55 is about here, up until the median. So this whole box represents 25% of our data. And so it looks to be that more of our data is going to be, even though the box plot is smaller, because it extends out into the whisker for Tinytown, that would probably have the greater percentage of homes. Okay. Which city has the greater percentage of households with real estate values above 85%? Or 85,000? Well, 85,000 is the median for both data sets. And so what we know is that we have 50% of our data above the median. So they actually have the same percentage because it's the median for both sets of data. Once again, greater variability is just which one's longer. That would be Big Bird. All right. Which interval contains the greatest amount of data from the box plot? So we're looking at 0 to 50. So because the whisker stops at 25, 0 to 50 only contains 25% of our data. 50 to 100 would be 25% plus whatever amount is up until 100. 75 to 125 is only 25% of our data. And then 125 to 175 is going to be a little less than 25%. So I'm going to just go ahead and say that's 50 to 100. All right, a student survey was conducted at a major university and data were collected from a random sample of 750 undergraduate students. One variable that was recorded for each student was the student's answer to the question, what region of the country did you live in just prior to enrolling in the university? Which data sets, or these data would be best displayed using the following. IQR is not even a type of graph. IQR is the interquartile range. It's the difference between your third and first quartile. And then we have these four graphs here. Stem plots, histograms, and box plots are good ways of graphing quantitative data. Pie charts graph quantitative or categorical, and region is categorical. All right, box and whisker plot again, or a box plot. Choose the correct label for the point on the box plot represented by the question mark. So we have to know how a box plot summarizes the 5-number summary. So your lower whisker is your minimum. Your upper whisker is your maximum. The middle bar here is your median. The left end of the box is your first quartile. And then your right end point is your third quartile. Which of the following are the appropriate numerical measures to describe the center and spread of the above distribution? So for distributions that are symmetric, we want to use the standard deviation or the mean. They're very good measures of center and spread for symmetric data. But when your distribution is skewed to the right like this one, what happens statistically is that these values here, because they're further away from the mean or from the center, those values actually pull away the mean. They make the mean greater than the chunk here. We say that the mean and the standard deviation are not resistant to outliers. They are affected by extremes in the data set. And because we have these extremes here, we want to use something else to describe the center and the spread. In this case, we would want to use the median. The median is resistant to outliers. Values that are extreme or away from most of the data do not affect it. So we want to use the median. And answer choice D is the only one that includes the median. And because we have the median, we want to find another resistant measure of spread, which is the IQR. All right, the distribution of IQ is approximately normal in shape with mean 100 and standard deviation 15. According to the standard deviation rule, what range of IQ scores do 68% of people have? So 68% is one standard deviation away in either direction. So we do 100 minus 15, which is 85, and 100 plus 15, which is 115. Okay. The cost of taking your pet aboard the air flight with you in the continental U.S. varies according to the airline. The 5-number summary for prices based on a sample of major U.S. airlines was, we're given the 5-number summary. Which of the following is true about this data? So what we want to do is, it talks about outliers. So we want to know, there's a formula to determine outliers that use the quartiles and the minimum and maximum. So we can find a lower threshold for what would not be considered an outlier, and anything below this value is considered an outlier. And we can find an upper threshold to determine what's the maximum value that we allow in our data set that wouldn't be considered an outlier. And then anything above that would be considered an outlier. So the way that we do it, it's going to be our minimum, 60, minus 1.5 times the IQR. And the IQR is just the difference between your third quartile, in this case 125, and 100. So in our data set, what did I do? I have to do minimum. That makes no sense. I misspoke. It's going to be Q1 minus 1.5 times the IQR. So, sorry, I said minimum. I didn't mean that. It's 100. So basically, any value below 62.5 is going to be an outlier. Is going to be considered an outlier. And we know our minimum is 60, and that's below 62.5. So we can see that the lowest price is actually going to be considered an outlier. And just to show you how to find the upper value, we're going to take our Q3, 125, plus 1.5 times the IQR. 125 minus 100. So any values above 162.5 is considered an outlier. Well, our maximum is 150. It's not above that, so it's not an outlier. Okay, a survey was conducted to study the relationship between a college student's age and the value of the car they drive. Data were collected from a random sample of 300 students from a certain college. The values of the students' cars were found using Kelley Blue Book. Which of the following would be meaningful to study the data on the study? Well, we're looking to see a relationship between the age and the value of the car. So a side-by-side box plot wouldn't be helpful. I would say it's going to be a scatter plot. We can make a graph of the age of the car and the value. So your explanatory variable would be age. That means the variable on your x-axis. And your response variable would be the value of the car, or the y variable. Okay? We have a relationship here. We're just asked to describe it. Well, what you'll notice is that we're looking to see, from temperature in degrees Fahrenheit, we're looking to predict the number of cans that we sell in some scenario. And what you'll notice is that as the temperature increases, we sell more cans. That's what's called a positive linear relationship, or a positive relationship. If one of the variables decreased while the other one increased, that would be a negative. So we have a positive linear relationship, and you can kind of look, it looks linear. But we have this one value here that's kind of away from everybody else. So we would say positive linear relationship with an outlier. Okay. Which of the tables is the appropriate table of conditional percentages to discover if the region where one lives affects whether or not one has health insurance? Oh, okay. Cool. So what we're looking at is which of the tables is the appropriate table of conditional percentages to discover if the region where one lives affects whether or not one has health insurance. Okay. All right. So from these tables, we look and see which of these kind of displays better what percentage of people are insured or non-insured. What? Oh, I clicked on the image. So let's look. Table A, we have 100%, so 12.6% of people in the Northeast are uninsured, 87.4%. Okay. So we just want to know affects whether or not one has health insurance. Well, these two, kind of, to be honest with you, are kind of, no, they're not the same, I just saw. 100% are uninsured. I would say table B. Basically, let me just talk you through it for a second, because this displays that, let me just see if that's right. 18.5% are in the Northeast are neither, that might not be true, insured or uninsured. And then, alright, so what I'm looking at here is actually that probably doesn't really tell you anything because it just tells you here, Northeast 18.5%, but really in the grand scheme of things, what does that say? So if you're looking though, you're looking to see conditional upon what region do they live in. Is there a relationship between having insurance or non-insurance? And that's what this tells you. If you think back to that row problem that we looked at before, here, that's on Excel, we can see like what percentage were dating given that they were not obese, what percentage was cohabitating given that they were not obese, and things like that. So table A gives you the row conditions of being insured, or the probability of being insured or uninsured given the region that you live in, and that will tell you whether or not the region affects insurance. Okay. A researcher wants to determine if preschool attendance is associated with high school graduation. She randomly assigns low-income children to two groups. One group will attend preschool program. The second group will not attend preschool. The researcher plans to follow the children in the study for 20 years and observe whether or not they graduate. So which of the following is the explanatory variable in this study? Well, that would be whether or not a subject attends preschool. We're looking to see, does attending preschool affect whether or not you graduate. So your response variable is the graduation. All right, a new study seeks to answer the question, does vitamin C level in breast milk of new mothers reduce the risk of allergies in their breastfed infants? The study concluded with high levels of vitamin C were associated with a 30% lower risk of the presence of allergies. So in this scenario, presence of allergies is what type of variable? That would be categorical. Basically a yes or no question. Do they have allergies or not? Okay. Calculate the column percentages. Okay, so it's kind of the same question as before, but now we're doing the column percentages. Let me clear Excel. Let me go ahead and copy this table into Excel. Remember, the first row is probably going to be shifted. Yep. Scoot it over. So we want to be column percentages. So for married, for obese, so we're looking at the percentages given that you're married. So this tells us that it already gives us 34.9. Let's just see that value. So conditional upon being married, what percentage is obese? 148 out of the 424 times 100. And there's our 34.9. Percentage 2 is not obese, so we're going to do 276 divided by our 424. Don't forget it's percentages, so multiply by 100. And that's going to give us 65.1. In addition, we know the total is going to be 100. So we could just do 100 minus 34.9, which gives you 65.1 anyways. Okay, same type of question, just a different, same data set, different question. Let's copy and paste this into Excel. Scoot this first row over again. So we want to know, based on the table above, the percentage of cohabitating participants who were not obese. So this tells us that we're only looking at cohabitating participants, just this middle column. And we want to know what percentage are not obese given that they are cohabitating. So we want to know the percentage of not obese given cohabitating. So that's going to be 327 who are of the cohabitating, not obese, divided by the total times 100. Not 4,100, 100. And we want rounded to 1 decimal place. So that's 76.2. Okay? High blood pressure is unhealthy. Here are the results of one of the studies that linked high blood pressure to death from cardiovascular disease. The researchers classified a group of white males aged 35 to 64 as having low blood pressure. Okay, in this example, which of the following would be appropriate to calculate? Well, the correlation coefficient, no, because that pertains to two quantitative data. The 5-number summary, basically looking at median, Q1, Q3, all that stuff. The appropriate conditional row percentages. So they're looking to the research classified here. The result of the study. The research classified group of white males. So we're looking to see then. We've narrowed it down from we don't want the correlation. We don't want the 5-number summary, and we're looking to see about to death from cardiovascular disease. So we're trying to see. Can we predict cardiovascular disease or cardiovascular death to blood pressure? So that would probably, to me, say we would look at the conditional row percentages because we're looking to see the percentages based on blood pressure. All right, so what we're looking for here, though, is we're looking to explain cardiovascular death from blood pressure. Now, because your blood pressure is your explanatory variable in this case, they are the columns. So you're looking to see within the columns, is there a higher percentage of cardiovascular death? So we would say that this is conditional column percentages. All right. Scatterplot. The weight in pounds and cholesterol levels of several individuals was observed. The data are shown in the scatter plot below. The outlier on the graph is likely due to an error in recording the data. Which of the following statements is true? A reasonable value for the correlation coefficient R for these data is 1.2. Correlation can't exceed 1, so that's not true. If the weight were measured in kilograms instead of pounds, the value of R would change accordingly. Well, the units that you use do not affect the correlation. So changing the units will not affect it at all. If the outlier were removed, the correlation coefficient would increase, or if it were removed, the correlation would decrease. So if you remove this outlier, your data, the remaining data, are more clustered together. That will provide stronger evidence for a linear relationship, which would increase the correlation. Wow. Okay. 3 straight scatter plot. The circles correspond to females and the X's to males. Which of the following conclusion is most accurate? So we would say both scatter plots, it should make sense. As you get older, what is it saying? As you get older, your predicted life expectancy goes down. So that would be a negative correlation between gender and life expectancy. When conducting a survey, which of the following is most important reason to use a random sample? Well, to avoid bias, to get a representative sample, to get a significant result, to ensure a truthful response or answers to the survey's questions so that we can make causal conclusions. So we want to use a random sample so that, well, first of all, random samples ensure that a random sample is a sample in which every participant has an equal chance of getting picked and ensures a representative sample. And a random sample can help us avoid bias. Which of the following is an example of stratified sample? So what happens with this chapter is that students get 2 types of sampling confused, stratified and cluster, because both of those sampling methods involve breaking up your experiments or your subjects into groups. But it's what you do with the groups that differentiates a cluster sample versus a stratified sample. So in a stratified sample, what we do is we break the participants into groups and we randomly sample from every single group. In a cluster sample, we break our participants into groups, but we sample everybody within some of the clusters. So with stratified, we sample from every group. From cluster, we sample everybody within a cluster. So in order to assess student satisfaction with the food establishment on campus, the first 50 students that come out of the student center were interviewed. That will be a convenience sample. A poll asks a random sample of 1,112 adults whether they believe in the use of marijuana. Well, random sample, that's its own type of sampling. A health educator wanted to study the sleeping habits of the undergraduate students in her university. For her study, the researcher chose a simple random sample of size 150 from each of the classes. So that would be a stratified. We have our classes, freshman, sophomore, junior, senior. Those are our groups. And that would be our stratified. We have each group, freshman, sophomore, junior, seniors, and we're taking a subset from each group. Okay, the faculty senate at a large university wanted to know what proportion of these students thought a foreign language class should be required for everyone. The statistics department offered to cooperate in conducting a survey, and a simple random sample of 500 students was selected from all the students enrolled. A survey form was sent by email to these 500 students. Which of the following is the appropriate sampling frame in this scenario? So we are looking at a simple random sample of 500 students from all students enrolled in statistics. So our sampling frame here is going to be the 500 students who got the email survey, all students enrolled in a statistics class, the students who responded to the email survey, all students who think that foreign language classes should be required for everyone, and all students at the university. So in order to do this, though, we need to figure out what is a sampling frame. So the sampling frame is the list of potential participants that you're going to ask. So because the statistics department selected a random sample of 500 students from students enrolled in statistics courses, our sampling frame is all students enrolled in statistics classes or courses. 2 questions left. The faculty senate at a large university wanted to know what proportion of these students thought foreign language classes should be required for everyone. The stat department offered to cooperate, blah, blah, blah. A simple random sample of 500 students was selected from all students enrolled in stat. A survey form was sent by email to these 500 students. True or false? Since the sample is random, it is representative of the population of interest. In this case, it's no. Because the students that were emailed really don't have to respond. That results in some type of bias. It's called non-response bias. And so it would not result in a representative sample. Really, I mean, probably students who respond either feel strongly about foreign language being required. And then lastly, talk show host Bull Loney asked listeners of his to call in about their opinion. That would be a voluntary response. If you're asking, people who just listen to you to respond, to call in, they are voluntarily deciding to respond. That is a voluntary response sample. All right, so let's submit this. Submit and finish. Remember, I didn't do one of the questions, so my grade won't be 100%. I skipped one. Yeah, there we go. Review this attempt. So let us see. Yes. Let's just make sure I didn't make any mistakes to lead you astray. That's right. And remember, I didn't do this one. Oh, I didn't read that one. I'm sorry. See, there's a negative correlation between gender and life expectancy. So if you look at this question here, question 34, there is another option that says there is a negative correlation between age and life expectancy for both males and females. And you can see that in the scatter plot. We have two groups, X's are males, circles are females, so actually that should have been the answer choice D. I didn't read all the choices. I saw negative correlation and assumed. So take what I just did as a warning for when you take your test. If this question were on it, make sure you read all of the answer choices. Maybe I can just go ahead and say that I did that on purpose, for illustrative purposes. And everything else is correct. So hopefully this helped you guys, and as always, if you need anything, if you have any questions on any of the other stuff, please email your instructor for clarification. Good luck on test 1.